In this lecture, we're going to be talking about independent events and mutually exclusive events. So let's start with independent events. What does it mean for two events to be independent of each other? Well, the idea is two events are independent of each other if this event does not influence this event in any way, and likewise this event does not influence this event in any way. And so the idea is there's no influence between the two outcomes. So in this case, or events I should say, in this case a way of saying that is the probability of A, given that B has already happened, is still just the probability of A. So this means that whether or not B happens or not, it doesn't matter. The probability of A is the probability of A. B has no influence. Likewise, the probability of B, given that A has already happened, is the probability of B. So if A happens or it doesn't happen, doesn't really matter. The probability of B is going to be the probability of B, whether A happens or not. Last but not least, the probability of A and B is going to be the probability of A times the probability of B. And this is typically the formula used when you know that A and B are independent of each other. So for example, typical problems involving replacement of cards involve multiplying two probabilities. For example, I have 5 cards here, and if I draw 2 cards, with replacement, there are a total of 25 possible outcomes. And you can list off all the different outcomes through maybe doing this and this, this and this, this and this. Like, it would be a long time writing out all 25 possible outcomes. Now, there is a king in this deck. This is a deck of 5 cards. There's only one king in this deck of 5 cards. What's the probability of drawing a king? 1/5. But what's the probability of drawing a king 2 times in a row? Well, in that case, it would be 1/5 times 1/5. But the reason why it's 1/5 times 1/5 is because the two events of drawing cards are both independent of each other, because I replace the cards. In both scenarios that I draw cards, there are 5 of the same exact cards. So the two events are considered independent of each other. Now let's talk about mutually exclusive. What does it mean for two events to be mutually exclusive? This basically means that the two events cannot happen at the same time. Like, for example, and I'll give you the notation real quick. The probability of A and B, in this case, is 0. So, like, let's say you flip a coin, and you want to know what's the probability that it's heads and tails. So, let's see. Lost my quarter. Don't know where my quarter is. That's all right. This is kind of an obvious question. It's 0. Because you can't get a heads and a tails at the same time. They're mutually exclusive events. Either one happens or the other. They cannot both simultaneously happen. Now, in some cases, it's possible for neither event to happen. Like, for example, rolling a die. You could roll a 1, a 2, 3, 4, 5, or 6. But rolling a 2 and rolling a 3 are mutually exclusive events. You cannot draw a 2. You cannot roll a 2 and a 3 simultaneously. However, you could possibly not draw or roll a 2 or a 3. You might you might roll a 1. I keep mixing draw and roll in this lecture. That's okay. But yeah, in this case, this is 0. Another example, what's the probability of drawing a red? That's not an R. A red and a black in a typical 52 card deck? Well, none of the colors are red and black. They're either red or they're black. They're mutually exclusive things. So in this case, it's 0. Anyways, I hope this helped. Thank you guys so much. I'll see you in the next lecture.